if we did polar, just polar?
Yes.
Very good. Very good.
Yeah, there's a lot of paying attention. Welcome to 8%.
I'm not charging you. Charge you in the shower. I shower and charge you.
I'm back.
How could you? I can never forgive you. I'll forgive you on one condition.
Put the next one upside down. Why does he keep rotating? Oh wait, no, that one's good. This one's the other one.
Which, I don't know why, every like your rights to.
I bet you watched it.
And I'm like, I guess I should stop playing, and I'm like, that's your age.
I had to go over
And
you.
you should know over entirely, but also X-Men.
You forced my hands.
I'm not.
I'm gonna get a station so I can get a chance.
I lost to it.
We should watch the intention.
How's the match go?
Dude, I'm behind like 12 shots.
2 seed Australia.
I can just tell you what happened.
Lost.
No, that's not the same.
Or you like
I'll tell you everything that happened.
I don't actually.
No, I know. It's actually a good book. I like to read it. I will text Nicole and you. I'll text Nicole. He still has you like.
you Jason Dale.
Oh, was it really loud?
Well, most days it doesn't come on the intercom, so if it does come on the intercom,
Everyone was saying it was quiet, so I was like, oh, my name is Lisa. Okay, good.
I figured it out, I think.
Oh, you did?
Yeah, it's pi over 6 to 5 pi over 6. That's why I was, yeah, okay. That's why I was struggling. It's because I just found the middle point, not like the actual point.
We have a test next to you. Alright guys, this is going to be your last chance to ask questions from class 27, and then I'll be asking you to turn this in. Since you had to finish this up outside of class, I thought there might be a question or two near the end that you needed help with. That's the only reason I didn't say you had to turn it in at the start of class. So, is there number 27, this one where we started polar? Any question near the end of the assignment you wanted help with? Yes, Lana.
On number 2, why do we add 2 pi to the angle?
Because the angle needs to be between 0 and 2 pi. It just didn't meet the directions without adding 2 pi.
Okay.
Okay, other questions on 29? Yes, Lana.
On 5, will that question show up on the AP exam?
Graph something like that?
Yes. Without a calculator.
Yes. Now, they're not going to say graph it, but you need that skill for the second part of this lesson.
Okay.
Without graphing it and understanding how the points are being created as theta gets bigger, you have to be able to find those angles to be able to do the area stuff. Were you here last time?
No.
Okay. So the second lesson in polar is about area, and there's a formula, and the formula is easy, and you just plug in R, which is usually given to you, but you have to find the angles, and to find the angles, you kind of have to understand what's going on with the graph, which is where the graphing thing comes into play. And that's honestly the graphing part. What you're complaining about there is why people think polar can be hard, because we do have to practice and get better at it by hand. Okay. All right. Another question. I don't want you to get up again, so I will ask you to turn this in before lunch. Some of you already gave it to me, and that's great. But I'll ask before lunch so that I have it and can give you some points. So that is good. Your third period. Okay, so we need to spend a good amount of time on section 9.8. So last class we just did the notes. I tried to forewarn you what these questions were going to be like and what the challenges these are going to be. I also, I think, unless I forgot, forewarned you that the third and last section on polar is also about area, but it's going to be the area trapped between two polar curves. So it's similar to last year when we found the area between two curves, and we just take the bigger area, found the smaller area, and when you take the big area, subtract the small area, it can leave behind the area that you want. So we will be doing the same thing with polar, where if we can find the area of some shape, and then we can find the area of it that's not part of our answer and subtract it away, we can find out how much area is between those two polar curves. So that is completely off the table until you can find the area bounded by a polar curve, because that's basically doing it twice and subtracting them at times. So the first part of our notes, again, this part isn't as important. It's good for you to see this stuff for your math, to see how some of the stuff is connected. It's not important as far as surviving the questions. But there was a geometry formula, 1/2 theta r squared, works great for circles, but as soon as the edge is not a nice consistent curvature to make it a perfect circle, all of a sudden everything you learned in geometry doesn't really work. So basically we talked about if we can split this into an infinite number of infinitely thin segments and add those together, that's the same thing as finding the exact area under the curve. So here is the same formula from geometry, 1/2. The theta, how big this theta is how it's changing. So delta theta, how much you have to go from one to the next, which we really want to be infinitely thin, times r squared, and r just represents the length, which sometimes we call f of theta, same thing. The function when you plug in theta is the same thing as r's theta, and it gives you that squared. So if we want an infinite number of those, we do the limit, but if you're doing the limit as n approaches infinity and you're going to add them all up of some stuff, that is the calculus limit definition of integration. So what you have to know is this formula. It's one of the easier formulas we've looked at. The area bounded by a polar graph is 1/2 integrate from alpha to beta r squared d theta. But even in the few examples we had time to look at last class, you could see that finding alpha and beta, finding those two angle measures, can be very challenging, especially because these are hard to graph. And without some graphing, you're just not going to know what those two angles are. You're not going to just look at an equation and say, oh, I need to go from here to here to get that. It's not going to happen. So we did a few examples. The first one was a great example because it was really a circle. So we could just do regular old pi r squared, or we could do what they did. But in this question, we started at theta equals 0, and we had to go till theta equals pi to enclose all of that. That's why I integrated from 0 to pi. In question 2, we wanted only half of the graph because we wanted this shaded region. Again, this question's on the easier side of this section because at least they gave us the graph, which is significantly helpful. So we had to find a point where this enclosed area started and ended, and that was 0 to pi. Then threw it in the calculator. Same thing with question 3. They gave me a picture, but if I want this area, I had to figure out when it started being this area, 2 pi over 3, kept going until I figured out that it stopped enclosing this area, which is 4 pi over 3, and then the rest was just a formula. 1/2 integrate alpha to beta r squared. R is given to you. The formula is always the same. Finding the angles, though, can be very tricky. They take a lot of thought. Okay, and then we did one more where we had 3 petals, and they asked us to find the area of one of the petals. So you could pick which one you did, but I chose this one over here. So this was 0 radians, this was pi over 6 radians, and then I could tell from my symmetry that this much of a turn was pi over 6, then this much of a turn was pi over 6. So I did negative pi over 6 to positive pi over 6. Or you could just do 0 to pi over 6. You can do symmetry, but then double it. So when I double the 1/2, that's why this one doesn't have a 1/2 and this one does, because it's got half the angles, so it half the area. So at the very least, that's what I needed you to get out of last class. There's a formula. Angles are tough. We have to practice the graphs by hand. It doesn't mean that every question on your AP exam is going to give you a graph without, or give you one of these questions without a graph. Sometimes they will, sometimes they won't. But when we start to look at these, you know, the first 2, 3, 4, 5, 6, 7 questions don't give us a graph. Not until question 8 do they give us a graph. And then it looks like from then on they do give us a graph. So we have to work through this, and this is quite a bit more struggle. It's not like some of the other stuff where, you know, you do one, you don't do it right, but you see what your mistake is, you learn from your mistake, you do a second one, you make a different kind of mistake, but you learn from that mistake, and then maybe by the 3rd or 4th one, if you're doing good, you just start getting them right. All of these, significant amount of time. We need several minutes per question on each of these, which is why I'm not even giving you the next handout today. Okay, so question 1. Find the area inside the smaller loop of the limison r equals 2 sine theta plus 1. Okay, well, good news is that's an area of a polar. So area is going to be 1/2 integrate from alpha to beta r squared d theta. My answer is going to come from that, and unless, and looking at this, unless this is something that we can integrate very easily by hand, we're probably just going to throw this in the calculator anyway. 99% of your thought, time, and effort needs to go into finding the angles, not any of the rest of this. So, first off, I need to know what this graph looks like before I even have a clue what they're talking about with the smaller loop. So, a lot of these questions will do something like, oh, well, you can see at the top of this page, there's one where there's a smaller loop inside of something else. So they're wanting us to find that smaller loop. Alright, well, now again, if they give you a graph, that's a little helpful. If you have a calculator, that's very helpful. So I'm not telling you to not do this. If you had a calculator, which you won't always, which is why we have to practice this in the difficult way, but you can graph this r equals in your calculator. Just put it in polar mode. You can see the graph. You can hit trace. You can move the cursor around, and then you can kind of see where the angle starts on the small loop and stops on the small loop. And honestly, that's probably a lot easier. It is a lot easier, but you're not always going to have access to a calculator. AP exam is going to test to see that you can do this without a calculator at times. So we've got to do the investigation and figure out the graph. Okay. So as you go through this, please, 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 on these polar things, slow down and make good looking graphs. Make an attempt to make a good looking graph. Even with an attempt, it may not look great. So to figure out what a graph looks like, again, sometimes there's some things you can do, like if there's a number next to theta, we talked about how that made petals, but that's not if there's a 1 there, so I don't know, can't use that. So really, my only tool that I have is to just start guessing. I need to start guessing some theta values and solve for r. So I have no idea what this is going to look like. I just have to dive into it. If I plug in 0 for theta, I get 2 times 0 plus 1. So in the 0 radians direction, you go 1 and plot your point. So r comma theta. Now again, I really think that labeling your points on your graph is going to make your life easier, because it's going to help you see how the graph's being created as theta gets bigger. I really think that you should do that. Okay, I don't know. You can pick whatever you want to. I'll pick pi over 2. The sine of pi over 2 is 1, times 2 would be 2, plus 1 would be 3. So in the pi over 2 direction, it goes 3 and plots a point. So here is r comma theta. Now, the frustration is, this is when theta is 0 radians, and this is when theta is pi over 2 radians. So it's not like in Algebra 1 where, you know, it's a linear line and you just get to connect these two. There's some curvature. It could be doing, I don't know, all kinds of stuff between those. So if I want to know a little bit better about how these 2 points are connected, I should think about something between 0 and pi over 2. Find an angle in between those, because if I get another point between these, I can start to figure out how these are supposed to be connected. So I don't know. I'm going to pick one where sine is a half, because I know if I can make sine be a half, multiplying it by 2 and adding 1 is just going to be a nice whole number. So where's the first time that sine is a half? Pi over 6. So a half times 2 would be 1. Add 1, you get 2. So in the pi over 6 direction, which is roughly this way, you should go out 2 to plot the point. Now this is at a diagonal, so that's a little bit harder too. And this is where it's not going to be easy to do perfect, but I go 2 in the pi over 6 direction. Now that helps me out quite a bit. If this is a high stakes question, this is a test question, and I've got some extra time, I might find some other points between 0 and pi over 2 to be sure about what's going on here. But I think what's going on is I think there's a curve, something like that. And again, because I'm labeling these points, I can think about how this is being created as theta gets bigger. Theta starts up at 0, theta keeps getting a little bit bigger. Here's where it is at pi over 6. Theta keeps getting a little bit bigger. Here's where it is at pi over 2. And now I can at least kind of understand that it's probably going to keep going this way, and it's probably going to keep curving. So, I don't know. Plug in something else. Pi, you get 1. So in the pi direction, go 1 and plot it. I don't know. Try 3 pi over 2. That would be 1. So you're tempted. 1 and then 3 pi over 2. Okay, so you might be tempted to say this. All right, I have a pretty good idea of what this is doing, and then I know it's got to go through this point, and it's got to go through this point, and at some point it's going to start doing whatever. If you do that, you should know this is wrong in this question, because there's supposed to be a smaller loop. So I just haven't been accurate enough to even find the smaller loop yet. So I still have to stick with this, and I still need some more points before I understand what this graph is doing. Okay, so Derek, why don't you give us a point to try? Doesn't matter, you can pick whatever.
7 pi over 6.
Okay, so maybe we try 7 pi over 6. At 7 pi over 6, sine is -1/2 times 2 would be -1. Add 1 would give us 0. That's interesting. So in the 7 pi over 6 direction, we go 0 and plot the point. 0 in the 7 pi over 6 direction. So neither of these are correct, but let me emphasize why I think these points are so important. Does this A, I'll do in green, does this go to this point first and then to this point? Or does it go to this point first and then to this point? How do you know which one it goes to first? How do you know if it goes to this point first or this point first?
Pi comes before 7 pi over 6.
Right, we're thinking of these as the angle gets bigger. 0, pi over 6, pi over 2, pi comes next. So it's actually going to go down here, and then right after pi comes 7 pi over 6. So very quickly it's going to this point. Does that make sense? Okay, so there's 7 pi over 6. I don't know. Why not try 11 pi over 6? I know 11 pi. The reason I'm picking 11 pi over 6, again, you can pick whatever you want to. More points is always better. When you guys have questions, and you will, I'm going to look at your graph, and if I can't tell what's going on with your graph, I'm going to say make more points. Not because I'm trying to be rude or trying not to help you, but if you can't see what's going on yet, it's because you don't have enough of a graph. If you don't have enough of a graph, you need to create more of a graph by plugging in more points. But I am picking 11 pi over 6 because I'm making an educated guess here. At 11 pi over 6, sine is -1/2, which is just an easy number to work with. I know the decimals for square root of 3 over 2 and square root of 2 over 2, and so that's fine if you know those decimals. Those help you create the graphs also, but otherwise I'm trying to stick to stuff like this. So at 11 pi over 6, which is this way, r is 0. So 0 in the 11 pi over 6 direction. Okay, well, and if I keep going to 2 pi, if this is 11 pi over 6 and this is 0 radians, but 0 and 2 pi are the same, so they're going to have the same value and they're going to fall in the same point. I get this. I still don't see a smaller loop. So where's the smaller loop supposed to be?
Between 7 pi over 6 and 11 pi over 6.
Correct. 7 pi over 6 was here, 11 pi over 6 was here, but that's a big jump. Think about unit circle. 7 pi over 6 is here, 11 pi over 6 is here. I didn't plug in any angles between 7 pi over 6 and 11 pi over 6. So there's a big jump in work there. So maybe I would pick something between those, like, oh wait, I did 3 pi over 2, didn't I? 3 pi over 2 would be, you were correct, -1. So if you do make a mistake, if you do enough points, you're probably going to stumble upon it because it's not going to be consistent. So this is supposed to be -1, which is actually up here. Alright, now this is starting to make sense. Here's pi. Next up is 3 pi over 2. And then that's where the loop comes from. So this gave me this point. Okay, so anyway, I did enough points finally. Again, hopefully you would pick, I'm not saying that you can't make this more efficient by making educated guesses, but you got to do enough to see that loop. I can see that this loop starts and ends when r is 0. When r is 0, it starts closing this area, and when r stops being 0, it starts including this area. So over here, since I made a table and I made all this easy to see, it started being 0 at 7 pi over 6, it ended being 0 at 11 pi over 6. So all of that to figure out that I want to start enclosing the area at this angle and stop enclosing it at that angle. Now you can throw all that in your calculator and you get the area. Again, keep in mind that this is worst case. Worst case because we're doing it without a calculator and we're doing it without a graph. So anytime they give us a calculator or give us a graph, we've got other options and it can be easier. But on the harder end, this is what we've got. Okay, what I want you to do is I want you to try to make the graph for question 2. So make a table, pick some theta values that you think are going to work out pretty nicely when r is 2 plus 2 cosine theta. Plot those points on a graph, and I will give you a few minutes to do that and for you to see how close your graph is from being correct. But also, I guess before you get too far in there, let's go ahead and write out the formula we're going to use. It's going to be integrating, or 1/2 integrating. Don't forget the 1/2, by the way. That's easy to do. Integrate from alpha to beta. I'm going to put highlighter there so I remember that's the hard part, of r squared d theta. The only challenge, which it is a big challenge, is figuring out those angles. You have no chance of figuring out those angles until you have some experience making the graphs. Now, I want to give you a few minutes to try this, because if I just keep doing these, it's easy to follow along and say, okay, yeah, there's a unit circle point, you put it on the graph, there's a unit circle point, you put it on the graph. It's easy to follow me and think that you can do that, but you've got to try it on your own. That being said, this one does have a hint in it. It says that the region enclosed by the cardioid. So what does the cardioid look like? Heart. So when you graph this, if your graph doesn't look like a heart, something's wrong. So that's also a hint on the graph piece. Okay, like I said, I'm going to give you a few minutes here. If you think you have the graph right and you think you know what those two angles are, feel free to throw them in your calculator, see if it's giving you the right answer that matches up with the class website. And I guess if you are doing it right, you can move on. It's not that I'm going to be saying anything new for the rest of this handout. It's just that these are so hard. I want to be there with you and hopefully help get you over some of the common problems. But I guess in theory, I have told you everything you need to know for this unit. So you could be working at your pace if you actually have it down. gonna give you another minute or two for this graph, and then I'm gonna show what I did. And then finished or not, I'm gonna ask that you steal from my work and give it another shot on the next question. Okay, so here is what I did for this question number 2. Again, I gave you several minutes to try to graph it. So I knew I was going to need a bunch of points, so I started off with my table, and before I even started making the graph, I just knew I was going to need a handful of points. So I started picking out all of the values of beta that I thought would work out nicely. I didn't want things where cosine was square root of 2 over 2 or square root of 3 over 2. I wanted things like a half or negative a half, 1 or 0, things that I could compute easily. I could always backtrack and find others. So I found a bunch of points. Didn't know if I would need them or not, but eventually I went from 0 to 2 pi, and those are coterminal, so of course they both gave the same value. I put those points on my graph. 4 in 0 radian direction, 3 in the pi over 3 direction, 2 in the pi over 2 direction, 1 in the 5 pi over 6 direction, 1 in the 7 pi over 6 direction, 2 in the 3 pi over 2 direction, 3 in the 5 pi over 3 direction, and then back to where it started. And now that I've plotted those points, I know how to connect them because I'm thinking about how these theta values get bigger. Maybe I didn't put them in order on the table, and if that bugs you, you could put them in order on your table. But I know I started at this angle, and then the next biggest angle I found was out here, and then here, and then here, and then here. And if I just connect them with my best guess, my answer looks a little boxy because again, I'm only doing a handful of points instead of hundreds of points like your calculator would do. But it's enough for me to see what I need. It's a cardioid. I knew it was going to be a heart, and it is a heart. Doesn't mean it has to be front facing. It could be tilted sideways like that. Okay, so finally, up here, what angles, if I want to get all of that area, what angle could I start at and what angle could I end at for this to work? Okay, 0 and 2 pi. Is everybody okay with that? You start here and you end here. Okay, so you can go from 0 to 2 pi. Okay, I want you to think of another one though. What's another one that I could plug in angle here and here and make that work? You see how I took something away from the formula? I took away the 1/2, right? So what if, do you see that there's symmetry in this problem? You could, and I'm not saying this is easier, I just need you to know that this is an option. I could just find the area from 0 to pi and double it, and that would be the same as the area of the whole thing. So do y'all see how these two are the same? Half as much angle, half as, well, don't assume that half the angles means half the area, because that's not always true. But 0 over pi is half the area of 0 over 2 pi for this polar equation. So I could just double this, and when I double it, that 1/2 goes to 1. So both of those would give you the same answer. Both of those are perfectly fine. It's not the only ones you could do, though, by the way. You could do pi to 2 pi and double it if you wanted to. I don't know why you would, but you could. Okay, so try to figure out what about that graph caused you the most issues. If it's unit circle, then maybe making yourself fill out a blank unit circle a few times would be a good idea. Plotting the points, if you need help with that, or if you just made careless mistakes, whatever, but you need to try to learn from the graphing so that it slowly starts to get easier. Okay, we have 10 minutes till our lunch break, so what I would like you to do is try to do the graph on question 3. I would like you to please, well, I guess we need to finish question 2, but really we just need to throw this in the calculator. $18.850. Okay, I would like you to try to make the graph on number 3 by hand. So make some points, plot the points, do a few more, plot those points. Once you think you are very confident in what the shape of the graph looks like, if you think you could find a start and end angle to get all of that area, then you can check your answer with the solutions online, and or you can also check your graph by graphing it in the calculator. So remember, you have to switch the mode to polar, and then it goes from y equals to r equals. So you can check in your calculator, but you need to try to do it by hand first. Don't just do it in the calculator and then sketch it to your paper, because then there's going to be a bunch of stuff that you're not getting the practice on that you need to. But do a good job with a picture on number 3 in the 10 minutes before lunch, please. We've got about 4 minutes, so we will talk about this graph when you come back. Feel free to keep working on that. But I do also need your 9.7 homework. So that was assignment 27. So 3 of you turned that in before class. You did not have to turn it in before class because I told you I'd let you ask questions. But the rest of you need to make sure that you give me that before you head out to lunch. I'll be back in just a second. I gotta start my food. Over time, people just put the trash in. So every once in a while, I would just dump them all on the ground before school and then make everybody walk over all their trash.
People are so lazy.
So they could see.
I'm trying to graph your own too, and I put in pi, right? And so I got like 2 plus 2, which is 4. But if I
No, you don't get 2 plus 2. At pi, cosine is -1, so you get 2 minus 2, so you should get 0 in the pi direction.
minus.
I ended it with shiny. look, it's because I started 3 different translations of that same Zeus book. And I was like, okay, wouldn't it be cool if we had these imperfect translations but also the same language? No, it would not be cool. Because this is so yeah.
Got to turn in before lunch.
I only just did. I wanted to see what his comments were. Because he gave me 100 and stuff. Because I'm just
Whoa. I just saw
Yes. Yes.
Oops, that's not it at all. Okay, guys. With our second half of class, what I'd like you to do is, obviously I want you to keep working on this assignment 28. So I need you to finish assignment 28, and then like we did with assignment 27, next time I see you, which is not Friday because there's no school, it's not Monday because there's no school, it'll be Wednesday. I know PSAT is on Wednesday, but classes are still like 50 minutes long. So in that 50 minutes, I will let you ask a few questions if you're having trouble with some of these. Now, if you get to some while you're here, you should ask. So I'd had you try to do the graph in number 3 before you left, but if you need help with that one, or if you get stuck with the graphs or any of the other questions, I would be happy to help you while you're here. But otherwise, please have those ready to go so we can tackle those on Wednesday next week. And then move into the last part of Polar. And again, the last part of Polar builds upon this section. So even though these are kind of tedious, especially finding the graph, please make sure you're putting in your full effort there. I really think it will pay off for you. Okay, I'm going to take a few minutes to get the homework papers put in and back to you. And then anytime after that, you guys want to ask for some help, I will. Hold the scale again for me. Yep. Okay. Well, because when you're plugging it into a calculator, so you solve this for R, right? And that's what you grab. Now remember, when you take the square root of both sides, it's really plus or minus.
Oh, okay,
So
so
if you-
it did imaginary numbers.
No, it only grabs the positive version of those, but there's also a negative version. So if you graph that and the negative version of that, it should give you the full graph. So,
I don't understand.
okay, well, what about it?
Like, usually we just like have this, the integral of this minus the integral of that.
Okay, top minus bottom, sure. But you're trying to find, oh, that's in terms of theta. I haven't read this question since last year, so let me try it on my paper first. That way, it'll be a little more efficient. This you? Yeah. No name on it? Yeah. What number was that, Derek?
11.
Alright, so you've got the formula, good. You understand why it's 0 to k? No? Okay, because here at the start, this is 0 radians. And then when that area is done enclosing is right here. But that point, since this is the line theta equals k, it's like this point would be k comma theta, except that k is equal to theta. So the angles you want are from 0 to k. That's why that's 0 to k. And then it's 1/2 r squared. So if you square that, now just anti-derive, raise the power by 1,